Hello, and welcome back to Shiksha Costa. Today we're going to be looking at the three primary trigonometric ratios. And those are called sine, cosine, and tangent. In this video, you will investigate, or you will determine through an investigation, when you have a right triangle and you have the ratio of two sides of it, and you compare that to the ratio of two corresponding sides in a right triangle that's similar, you get these three very specific, very special ratios called sine, cosine, and tangent. And you can use these trig ratios to determine a side length or an angle in a right triangle. To start off, I'll ask you to pause the video here and answer this question. Determine the length of the hypotenuse, the side opposite the angle, and the side adjacent to the angle in both triangles. Pause for just 30 seconds here and see if you can answer that. Okay, well, hopefully you looked at this triangle. You saw, okay, here's the angle. I know that the opposite side is probably not the two sides that are touching it, but the one side that is across from it. And so that's 1 centimeter. Adjacent means sitting or means next to or right beside. And there are actually two sides that are adjacent. This one and this one to this angle are two sides that are right beside it. So how do we pick which one is adjacent? Well, the answer lies in looking at the third side, the hypotenuse. Now, only one of these could be the hypotenuse. Only one of these is the longest side of a triangle, of a right triangle, and that is this one right here. So the adjacent must be this one at 1.73, and the hypotenuse is this one here at 2 centimeters. Very similarly, if we go over to the next triangle, the opposite side to this angle is 2 centimeters long. The adjacent side is 3.46, and the hypotenuse is 4 centimeters. Now what I'd like you to do is determine the ratios listed for each triangle. So take the opposite divided by the hypotenuse, take the adjacent divided by the hypotenuse, and list all of those answers right over here. Take maybe 2 minutes to do that, and then see what you notice. Okay, so hopefully you are able to take the opposite, which is 1, divided by the hypotenuse, which is 2, and 1 divided by 2 is 0.5. Okay. Adjacent divided by hypotenuse, 1.73 divided by 2 is about 0.865. And opposite over adjacent, 1 divided by 1.73 is about 0.578. Now, if you look at this triangle, which is a little bit larger, we can see that the opposite divided by the hypotenuse, this would be 2 divided by 4, and that gives us 0.5 as well. When I take the adjacent, 3.46, and divide that by the hypotenuse 4, I get 0.865. And when I take the opposite, which is 2 centimeters, and divide it by the adjacent 3.46, I get about 0.578. The last question I'm going to ask you is, what do you notice? Pause the video right here and see if you notice anything. Well, there's lots of things to notice in the situation. One thing to notice is that, hey, this triangle is just a very, like a double this triangle that's double the size of this triangle. If you notice, all of the side lengths seem to have been multiplied by 2. Even this times 2 is 4. And 1.73 times 2 gets us 3.46. That's certainly one thing to notice, that these two triangles are similar and that this one is just a bigger version of this one. Another thing that you might have noticed is, hey, when I took the opposite side and I divided it by the hypotenuse, I got 0.5 in this triangle and in this triangle. Even though this one was bigger, even though all the sides were bigger, when I divided the two sides, I ended up getting the same number. And that happened for the adjacent over hypotenuse and the opposite over the adjacent. And so one thing to pull away from this investigation is that when you have right triangles, no matter how big the triangle is, if the angles are the same, then the ratios, which this is a ratio right here, all of these are ratios, the ratios of the corresponding side lengths are always the same as well. And by corresponding side lengths, I mean, if you take this angle over here, the opposite side and the hypotenuse, if I divide the opposite by the hypotenuse, like we saw here, we got the same number. And these ratios actually have very special names. The opposite divided by the hypotenuse is called the sine ratio. Sine of an angle, and this is a Greek letter here. I know you saw it pop up over here in the triangle as well. This is a Greek letter. It's called theta. And the sine ratio of any angle is equal to the opposite side divided by the hypotenuse. And even if that triangle is a lot smaller, as long as that angle is the same, the ratio will always be the same. The next ratio that you have to know is called cosine, and we write it like this: cosine of theta, cosine of an angle. The cosine ratio of any angle is equal to the adjacent side divided by the hypotenuse. And the last one is called tan. The tan ratio of any angle is equal to the opposite side divided by the adjacent side.
So in a right triangle, depending on which angle you choose, you can actually find the value of these three primary trigonometric ratios. And here are their definitions. Sine of that angle tells you the exact ratio of the side that is opposite to the hypotenuse. Cosine of an angle tells you the ratio of the side that is adjacent to the angle compared to the hypotenuse. And tan tells you the ratio of the side opposite the angle to the side that's adjacent to it. Simply put, SOH, so, CAH, ka, TOA, TOA, is a nice little acronym to use to help you remember the three relationships depicted here. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So TOA. Now, one more thing before we get into some examples is if you actually know the ratio, if you already have this number, maybe it's 0.5, maybe it's 0.7071. If you have the ratio already, you can actually use a function on your calculator to find out what is the angle that is associated with that ratio. All you have to do is look for these buttons on your calculator. These are called the inverse. This is the sine inverse, the cosine inverse, and the tangent inverse. You put the ratio, you press usually the second button on your calculator or shift or something like that, and then you press sine, cosine, tan, and you'll see just above those buttons, you will see this button with the little -1 almost looking like an exponent. That's the inverse function. And that will tell you what angle produces the ratio that's listed right here as x. In this example, in triangle DEF, angle E is a right angle and length DF is 13.4 centimeters, and angle F is 33 degrees. So over here, we have a right triangle. I've drawn a diagram. Here is DEF. E is the right angle, F is 33 degrees, and the length connecting D and F is 13.4 centimeters. If I want to solve a question like this, if I want to find out the side DE, I have to recognize that this side is opposite a known angle, opposite 33 degrees. And if 33 degrees is the angle I'm considering, then this is the hypotenuse, and this side would be the adjacent side. Now, because my question doesn't really need the adjacent side, I'm trying to find the length of the opposite side. I have the hypotenuse and I have an angle. Well, that question then tells me I need to use the sine ratio. This is the only one that compares the opposite to the hypotenuse. So that's the one I got to go with. And the sine ratio tells me sine of any angle is equal to the opposite side divided by the hypotenuse, SOH. The angle in question is 33 degrees, so I'll plug that in there. The opposite side is my unknown value, length DE, and the hypotenuse is 13.4 centimeters. Now, to isolate my unknown value, I just have to get rid of 13.4, so I'll do the opposite of dividing, which is multiplying. That will cancel it out, and then I multiply the other side by 13.4. And now, what is sine 33? This is, like we talked about, a very specific ratio. And you can find out what that ratio is by putting the number 33 into your calculator and then pressing the sine function. And you should get a number that's approximately 0.5446. And there's many more decimals after the fact. But then you're just going to take that exact number, that whole number, and multiply it by 13.4 to find out the length of side DE. And that's about 7.2982, which will round to the nearest tenth, 7.3 centimeters. In this example, we're going to find the measure of side length B to the nearest meter. Well, none of these side lengths are even labeled, so how the heck are we supposed to do that? One particular way that we denote triangles is that we always label the side that is opposite an angle with the same letter. Side lengths get a lowercase letter, and the corners or the vertices or the points or the angles, those all get the uppercase letters. So over here, we've got side B is actually this side over here, because that is opposite angle B. Now, armed with that knowledge, see if you can pause the video here and see if you can solve this problem. Well, in this triangle, notice that we know one angle that's 28 degrees. This side would be the side that is opposite it. This side would be the hypotenuse, making this side the known value, which is the adjacent. Now we're trying to find out the length of the hypotenuse. So this question is going to involve our angle, the side that's adjacent to the angle, and the hypotenuse. And that tells us to use, let's see, not an angle, because that, it does tell us to use the angle, but that doesn't really show up in SOHCAHTOA. But what does show up is, the hypotenuse and the adjacent. And so the only ratio that uses both of those is cosine. Cosine of this angle will equal the ratio between the adjacent side and the hypotenuse. And I know that that angle is now 28 degrees, so I'll start replacing values with their or variables with their values. And I noticed that this question suddenly got a lot harder. The denominator here is the length that we don't know. So in order to find out what it is, I can't have it in the denominator. It must be in a numerator. So I have to multiply both sides by the same denominator to cancel it out. And now I've got the unknown value here in the numerator, but I have another problem. It's being multiplied by cosine of 28. And I need to get it all by itself to find its value. Now, one mistake that a lot of students at this level make is they try and do the cosine inverse to get rid of this. But recognize that cosine of 28 tells you a very specific number. It's the ratio between this side and this side. And if that ratio was, let's say, 0.5, this side is half as long as this, no problem. This would be x times, or the unknown value, AC, times 0.5. And then to find out what that value was, you would divide both sides by 0.5. So this really represents a number. And to find out its value, I will divide both sides by that exact number. And that leaves me with just my unknown value on the left side and 16 divided by cos 28 on the right side. And you can put this into your calculator and it'll spit out the exact answer, which you can round to the nearest whole number, or the nearest meter, to get 18 meters. In this example, we're going to find the measure of angle A to the nearest degree. Now, if this is angle A, and this is, we're comparing this side here because that's one of the values that we know, this would be the opposite side, the side that is the only side that is not touching angle A. This being the side across from the 90-degree angle would be the hypotenuse. And this last side, whose length we don't know, would be the adjacent side. So in this question involves the angle A, the opposite side, and the hypotenuse. And that tells me that I should be using, so that combines the opposite to the hypotenuse, and that is the sine ratio. So sine of this angle, whatever angle that is equal to the opposite side divided by the hypotenuse. And of course, we know that 8 divided by 16 is 0.5. So that is the ratio associated with angle A. What is angle A? How do I find out? I don't need the ratio. I need the angle itself. Well, here, my friends, is where that inverse sine ratio comes in play. If I take the inverse of sine of the left side, it's sort of like division canceling out multiplication. These two are opposites of each other, and so they will cancel each other out. But whatever we do to one side, we have to do to the other side. So if you take the sine inverse of 0.5, you will find out that this angle A is exactly 30 degrees. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.